Hello and welcome to our strip down of the Eq8, the Skywatch Eq8. The owner of this mount has fitted a cover for his deck axis. This is the axis we're going to strip down today. We'll start by removing the cover for the encoder housing, which is these screws here. There is one hidden screw that necessitates the removal of the motor connection and worm cover. That cover there hides the last screw for this. What we'll do is we'll edit this here. Having said that, it seems sensible to remove the saddle first, and of course those are 3 screws there, and we'll remove those before we actually attempt removal of that cover. So I'll come back to you later and we'll continue then. Okay. The next cover we're going to remove is the deck motor cover itself, which is this particular item here. You'll notice that the ring, or the encoder ring, is quite clean. That in part is due to the cover that Matt's manufactured and fitted. And if you look closely, you can actually see the optical encoder that runs around here. It's a very thin grey strip and very delicate, so we won't be touching that at all. We'll just hopefully get off the clutch housing here and the encoder ring itself in one component. Okay, so the cover, as you can see, has been removed, exposing the stepper motor, and the next step we're going to take is to attempt to remove the 2 screws that hold the flexible coupling from the motor to the worm block, or the worm itself. With gentle teasing, they have come undone. Our next stage is to remove the motor from its holding bracket. Okay, so best 2 screws to remove are actually the ones that are accessible through a hole in the motor frame. That means that when this one and this diagonally opposite one come out, then the whole plate and the motor and the inner coupling there will come apart. So we'll detach that plug, remove the 2 diagonally opposite pins, and remove the motor from the coupling. That should leave the coupling in place, attached to the worm block, and we'll proceed after that. We also have the optical encoder here, but we'll come back to that in due course. So for the moment, those 2 diagonally opposite screws, the plug, and we'll then carry on from there. Okay, so we've now actually unscrewed the motor. The clip is very fiddly, and you have to be careful because there's not a lot of room here on the wiring, so take your time. We actually used a small flathead precision screwdriver to slip between the actual plug and its holder there, just to squeeze it out, and it worked a treat. It's come out fine and we're ready to proceed. We'll come back in a moment. So we're going to remove the encoder plug now itself. You have to be just careful. These are very delicate switches, but out it's popped with the aid of a little screwdriver there. Our next removal procedure is going to be the worm block itself, And in order to do that, we are first going to remove, and I'll just pop around here, we're going to remove the 3 blanking plugs that the modern Eq8 has. These give you access to the adjustment bolts for your worm and worm wheel clearance, which reduces or increases your backlash, of course. So we're going to remove those 3 blanking plugs. In addition to that, we're going to have to remove the 4 pins that sit at the back that hold the worm block against this body here. Normally under adjustment procedures you would simply back these off so it allows the worm block to float, but we're going to remove them completely and that should allow us to remove the worm block out through the top there. As you can see, the encoder is disconnected, as is of course the motor plug, and we are now ready to attempt that. I'll come back in a moment once we are finished with that, or at least we are halfway or part way through, and carry on from there. Okay, a quick edit. Before we actually remove the worm block, we're going to crack the bolts of the clutch housing, because there's clearly it helps us if the worm wheel itself is locked in position, and the worm helps us, the contact with the worm does that. So we'll crack these bolts first, and then we'll proceed with our original track, which was to remove the worm block. Okay, those bolts are now cracked, and we'll continue with our disassembly of the worm block and removal. Okay, so having removed the 4 pins from the block, or from the back there, that retain the block against the frame, we're now going to remove 3 screws. One is hidden under there, and the other 2 are there and there, and they should enable us to remove this frame. Once that frame is removed, we'll then go into the top and undo the centre pin, or sorry, the 2 outside pins, and they should, in theory, release the worm block, which we'll then be able to pull away from the worm wheel and free it off. The one thing we will attempt to be very careful of, and that is, as you can see, the encoder here, we don't need to detach it as long as we protect that worm block with the worm inside, and the encoder, we should be fine. So that's our plan, to remove those 3 screws and then the 2 outer screws that secure the worm block, and we'll remove it. So we'll come back when that's done and go from there. Okay, we are now we have now removed that bracket, so we're going to now continue and attempt to remove the worm block itself. With the end frame removed, you can just actually see, if I can maintain focus, the adjustment pins for the worm block. These ride on this parallel bar, or whatever it is, can't actually see it yet, but we're going to remove those pins out through this end and hopefully then remove the actual worm block. We should then be able to see the teeth of the worm wheel itself. Okay, we haven't actually removed the worm block yet, but it's worth noting that in order to remove the 2 outer screws, which themselves are actually cap heads, you need to loosen the centre one first, which relieves tension on them. So that's what we've done. We are now, you'll find now that the worm block itself is actually coming loose. There we go. We have decided to remove this end plate hopefully that will allow us to bring the worm block back. Matt's just undone the two there, you can see, and he's now doing the two outer ones. So we're now about to remove this top plate, and that should in fact actually free us the worm block in its entirety. It's now loose, of course, and we'll hopefully see this removed soon. There's the plate removed, and now we're hoping that Matt is going to be able to entirely remove the block, which he has. There's the block. There's the worm within the block, and the encoder still attached. There's the worm block protected and dust free. Okay, having undone those 4 pins on the top and this pin here on the side, we can now lift the encoder wheel itself from the disc of the worm wheel. It's stiff, but not too bad. There we go, off it comes, and we are left with the stub axle there, which fits in to this bore here, and hopefully that should be put away clean, and we'll go from there. Okay, so all the encoder wheel along with its clutch housing has been now removed, put away safely. We're now raising the declination of the mount to gain access to the electronics cover, which should give us access then to the bearing, housing, etc. Then we'll remove the counterweight threaded holder with these 4 pins, and we should see the declination axis shaft and its bearings in there, and we'll look at removing that in due course. Okay, we've taken off the screws for the electronic board cover. As you can see, we've not touched those 4 inner screws, just the outer ones. There are around 6 of them. Move that cover, there we go, and you can see that the whole thing has come, and now here comes the difficult part with wiring. We have to look at how we're going to disconnect the innards from that. We've now removed 2 pins that hold, and whether you can see it there we go, this cover, because that enables us to remove the wiring through that particular little gap. It's a little tight. Ideally we would have liked to remove this, but they are very tight, and we've decided against that at the moment.
I think we're going to have to take that off.
Right. Matt feels that because perhaps of the plug the other side, we may need to remove that, so we'll perhaps attempt to do that and then come back. But whilst I'm here, just to point out, we can actually see the homing peg here and its encoder reader there, and also the nut for the bearings of the declination shaft. So we'll continue to try and ease these wires out in a sensible way so that we can easily relocate them, and we'll come back in due course. Plugs are actually, or some of the plugs are actually glued in. Let's see if it's mounted onto the board. So if you move them, you run the risk of breaking the connection, which of course isn't what we want to do. Plugs such as the stepper motor wiring can be easily disconnected from its plug there, but we've left the wiring in for the stepper motor because the head of the wire or the cable head won't come through this little gap here without removing this whole block, and that appears to be at the moment fraught with some difficulty. We've managed to undo the pins, but it's still lock solid. We're now removing the worm block cover underneath in order to assert where the actual wires go and how best to remove them. This is our biggest problem to press, and we are hoping that this gives us access to an easier method of removing some of the cables to enable then removal of the motor board without too much difficulty. This is the RA encoder plug being removed. Okay, unfortunately we've been forced to remove the RA stepper motor to just basically allow us access to the wiring and that little alloy block, which will enable us to pull out the encoder cable. Okay, we're now in position where we're about to remove the aluminium block that holds the homing sensor, or at least the homing encoder. And the reason for this is, again, as I said, is simply because we can't remove the way it's wired is ridiculous. So now we can actually pull those wires through and save us messing about with the motor control boards. So that's all now dismantled, and we're about to thread through the cables. We've already threaded through the RA motor control cable, which is there. Fortunately, we've got a rather large hole here where the wires are able to feed through. It's just that due to the design, they are very, very tight, naturally very short. I don't know how much they save by cutting the cables down to an inch of their lives. Well, this is turning out to be quite a job. I don't know whether this video shows it very accurately, but the cable itself has been mashed on installation, and although they are not damaged, they are nevertheless close to damage. And again, the bracketry is just not big enough to pass the cables through easily, and so we have to, by the looks of it, remove that large alloy block, which we're about to do. That means essentially that in order for us to safely and without risk of damage to the wiring, remove all the RA drive components. A pain in the neck, but nevertheless we feel it's probably the safest option. This is the slot that the wiring is passed through, and as a point of note, this particular edge here is so sharp it would easily cut through the wires and probably cut through my skin if I were to put some pressure on it. So whilst we've got this particular item off, we are going to make it a little deeper just to enable better, and smooth it off, just to enable better passage for the wiring on assembly. We've also noted on disassembly, this block is actually the block that is used to tension the motor drive belt on RA. And though it's not that visible, the actual witness marks left by the adjustment screws are right on the edge of that alloy there, and so it's not really a good fit. We may consider, if it's at all possible, just packing this out by a mil or so, just so that the adjustment actually sits better on the centre of this, just to aid our assembly. On a normal operation, unless you get this far, I don't think it matters too much, but the sharpness of that particular alloy block can matter. Okay, we've now labelled up our cables so that we can easily fit them back there to their respective points, their encoders, etc. It's worth noting that actually they're quite well marked up on the board. So we've identified them with paper markings just as a precaution. Now the one remaining cable pops down here through the centre of the mount, and we're going to have to again disconnect that from down here, and we're going to remove this cover here, which is held in by 4 screws, which should give us access to its encoder, and we'll remove it from there. Okay, so this is the RA axis encoder, and the cable that's attached to it, well, when we've removed it, it should enable us to remove the motorboard. Okay, we've now successfully removed the electronic board and its cover, of course, all in situ, and we've not disturbed any of the clips that are hot melted onto the board there. As you can see, all the wires or cables are already now identified, and as a belts and braces approach, we are drawing up the connections here just so that when we reassemble we know where we are. Okay, so having moved the electronics board and everything, we are now left with the start of removing the declination shaft. But first we have to remove the homing tool encoder or its reader. The encoder, I think, sits on this particular piece of kit, which we won't move yet, but we're going to remove these 2 pins here. There are also 2 pins there, but we're hoping in removing this that we are able to slide off this cover and then give us access to those 2 pins, so then that whole thing is removed and gives us clearance. So we'll see. Yes, these are the this is the cover as it's being removed. You can see we've scribed it and marked it with a little bit of blue to give us some aid in reassembly. This has left us with this bracketry here that holds the encoder, so we're going to try and undo those 2 pins at the back. You can see that the position of the encoder shaft or flag is importantly right bang centre in between the 2 sensors, or very, we don't want them clashing when we reassemble. So those 2 pins are useful in positioning the encoder relative to the flag. Okay, we are now about to remove the bracketry that holds the encoder reader there. There we go, and we're left with the flag, and there is the bracket and the encoder reader. Our next disassembly procedure is to remove the counterweight bar holder. This will allow us access up through the base of the deck axis in order to push out the declination shaft. Okay, we've managed to remove the counterweight bar holder, and as you can see, there's a considerable amount of swarf in here. Not good at all, but it's not good good machining at all. I suspect they simply don't consider this an important component for the operational integrity of the mount, but we will of course clean it up, and this gives us access right up there to the declination shaft. We are now approaching the worm the deck axis ring. There's two or so grub screws in there which we're about to undo, that should allow us now to undo this bearing ring. And there's the second one, just about to be removed. This locks the ring onto the thread and stops it from coming undone, presumably. We are going to use a pin wrench. Oh, there's three. There's another one coming around. And we'll check to see if there is one more. But we think, it looks as though there are three at 120 degree spacing. So what we'll do now is we will use a pin wrench to undo this ring nut and therein release the deck shaft from the ring from its hold on the deck shaft. We'll probably have to secure the deck shaft with some kind of leverage on the front, and so two hands will be needed here, and when this is removed we'll come back there. Okay, so what we've done, we've introduced two pins into the flange there in order to leverage against undoing the locking nut. The locking nut has undone quite easily using the pin wrench, and we're now, if we can't undo it by hand, then what we'll do is we'll just loosen it a bit more, and hopefully, there we go, that should now undo. And that is of course now allowing, or will allow us to remove the lower bearing. The reason it's stiffening up in places is the grub screws that are introduced onto the thread to lock it in place actually do just damage the thread, but they are perhaps nevertheless important, as you wouldn't want it to come undone in actual operation. It's now about to exit the declination shaft, and we'll see what the condition of the threads actually are.
I don't see the damage on the threads there, just like Eq5s and 6s.
Okay, so there's the nut, and you can see the damage that the grub screws leave on the thread. It leaves a considerable witness mark there, and there are, as you can see, three corresponding marks for the grub screws. We'll now attempt to drive out the declination shaft from the bearings. It should go through that inner race, and the bearing should then fall out into our hand. Okay, we found that we don't in fact actually need to drive out the shaft. It is actually pulling out, which implies that the bearing fit on the declination shaft is extremely loose. Okay, we anticipate that this play shouldn't be there. Yeah, so we're going to try and address this in due course. Red thread lock.